get started. Welcome, everyone. We're so excited to have all of you here to celebrate with us some solutions providers, some innovators here that are really helping us to address a major industry challenge. This is all about our 2023 Open Innovation Challenge by the Cleveland Water Alliance in partnership with our very engaged utility partners here for detecting lead service lines without breaking ground. Just a little bit of background about this program. So the Cleveland Water Alliance, we are a nonprofit organization. We focus on innovation for the water economy. And our open innovation program specifically is focused on putting attention to big industry challenges, big gaps in the market that are ripe for innovation, and getting that challenge out to innovators all over the world to help us solve these issues. To date, CWA has invested over $500,000 directly into early stage innovation, and we will be soon launching a seed fund to expand some of the investments that we're making. This particular challenge is focused specifically on providing some grants to early stage concepts around this very important challenge. So one of the really important things to understand from the innovator's perspective about a challenge like the one we're going to talk about today is that when there's a significant market gap, that also tends to mean that there's a significant revenue opportunity for an innovator that may solve this. And it also means that there are potential opportunities for innovators when they're ready or if they're interested to collaborate with one another to provide a multi angled solution. So we may see one innovator that has one approach and another innovator that has another approach. They may choose to pursue those approaches and try to bring them to market, but they may also find ways to collaborate to make a more robust solution for pragmatic use in the market. And the revenue opportunity here is a significant one. So just a little bit of thanks to our partners and to give you a sense of the size of the market just here in the US. The EPA estimates about 9 million lead pipes currently delivering water to homes have lead in them. Some of us may remember the challenge around Flint, Michigan, when some of the lead in their pipes experienced a chemical change due to some of the treatments used in the water going through those pipes that corroded the pipes and in turn really caused some significant issues to the health of residents in Flint. And lead is a significant material used historically in pipes across the United States. It has significant potential health impact. Our panel of judges, our utilities, include the City of Cleveland, the City of Sandusky, the City of Cincinnati, the City of Akron, and Aqua, Ohio, which is has many utilities across the state of Ohio. And another thing worthy of note here is that this challenge is of interest to associations, collaboratives across the country, as well as the EPA specifically. We have also on this call one of CWA's partners that's representing interest from the Water Research Foundation. And some of the solutions that are going to be featured here will be also included in various reports to update the industry about solutions in the marketplace. With that, I'm going to turn this over to Brenda as I walk you through the various things that we're going to also be providing in support of the grants for these innovators, including technical advisory, research, facility access, and business and commercialization support. And with that, Brenda, you want to tell us a little bit about the service line research facility, and then I'll get you into the issue itself.
Oh, thank you, Evie. My name is Brenda Culler. I'm with Cleveland Water, and Cleveland Water, we have really good, solid water quality that's met all of the standards for safe drinking water for many, many years, including being well below the federal action level for lead. Yet we are very proactive in our pursuit of funding to take out lead service lines because we do have a lot of them, with the majority of them being on the city-owned side of material. A couple of years ago, we started partnering with Cleveland Water Alliance and various others to develop a research testbed facility at one of our locations. That location is actually in Parma Heights in our service area. So companies who can design products to test and determine pipe material without being intrusive, without breaking ground, without being in customers' homes, have a way to test their technology. And we're very willing and open to let companies come in when they contact us to use our service line research facility. Next slide. So we need technology specifically that can physically detect water service line pipe material without breaking ground and without using methods that rely on historical records. For our system, we have about 80% accuracy in finding where lead service lines are. We know that we stopped using lead service lines in 1953, so anything put in 1954 and more recent is not going to be lead, and we know where those locations are, but we are missing some of the historical records where we just don't know where replacements did occur. So for those locations specifically, a technology that's non-intrusive, does not go inside a water pipe, does not need to go inside a customer's home, is going to save us potentially millions of dollars in the long run. And we're just one water system. Next slide. So specifically, for Cleveland Water, we divide a service line pipe into segments A, B, C, and D. A is a city-owned service line material. A majority of lead in our system is located on the city side. B would be the customer-owned portion of the service line that connects with the city-owned portion. Near the curb stop box are typically located in a tree lawn. And for our system, service lines are about 5.5 feet beneath the soil. When you go into a customer's home, that service line is going to extend through the basement wall or the basement floor. That's indicated by C on this graphic. B and C typically match. It's a very rare occasion when they don't. And then of course we have D, which is a customer's premise plumbing material. What we envision for this technology is something that can be easily transported along the ground to tell us what type of material A and B are, fully knowing that there are some areas such as vault meter sites that may have a plethora of material underground that ranges from lead to copper to brass to galvanized steel. Next slide. So our detection priority is positively being able to identify lead, galvanized steel, and copper. There are some water systems that do have plastic service lines that could be connected to lead, so that would be an added interest. Then we also know that depending on where a public water system is across the country, how deep those service lines would be buried. In Ohio, up in the northern region of Ohio, where Cleveland Water is, our service lines are buried more than 5 feet beneath the soil. And in the lower region, where Cincinnati Water is located, who's a partner in this project, their service lines are more in the 3 to 4 foot range. As you can imagine, in Florida, service lines are pretty shallow, and then up in the northern states in Minnesota, they're going to be even deeper. Next slide. So we want a type of product that can be portable, self-contained, and give us feedback in real time. If we have 50 connections on a street and we are trying to determine what 40 of those service lines are made from to do replacements, we want to be able to go down the street and contact customers while we're using the tool to know where lead is located. We want it to be self-contained and have its own power source, either within the device or something that's readily rechargeable at the end of the day, or potentially connected to a rechargeable power source on a vehicle. And like I said, that real-time feedback of what type of pipe material is there without any back in the office processing of the data is also an extremely important thing for time management. Next slide. Our goal is to have a device that gives us a greater than 90% accuracy at finding where lead is. Being accurate at determining the lead, the galvanized, and the copper is important. So we as public water systems can be in compliance with federal laws that are forthcoming, new laws that are on the books. Next slide. What won't work? We don't want anything that breaches the pipe. Breaching the pipe, whether it's going inside the pipe or cutting into a pipe, can dramatically impact water quality in a negative manner. That's not something we're looking for. It also would require then either pipe repair or some type of flushing protocol afterwards. Entering a building. Customers' service lines are on their building sides. Many folks work and they aren't at home. It's very time consuming to schedule entrance into a building. So we want a device that can be used simply outside. And finally, AI approaches that are dependent on historical records. This is something that can be added to any type of physical detection. AI is allowed in some states, it's not allowed in others, but we really want a device that works by simply just going down the street with it.
So thank you so much, Brenda. Once again, I just want to acknowledge our panel of judges. So our panel of judges have really been involved with us shaping this particular open innovation ask for over 2 years. And we are really excited to have them engaged, really thoughtful input into looking at the various opportunities that have been put forth by innovators. And with that, I'm going to introduce Emily Hamilton from our team to talk about the process and the winners.
Thanks so much, Evie, and thank you, Brenda, for all of that context. I want to say that our panel of judges was really thorough and helpful in assessing the technologies that were submitted to us and identifying 3 that they thought were the most promising for this award. And I'd like to, without further ado, introduce those winners presently. So in 3rd place, being awarded $10,000 along with some auxiliary services, is Utility Technologies LLC. They are using a boroscope method, magnetics, and content testing. And I'd like to hand it over to Marc really quickly to put into his own words what his technology is. Marc?
Can you hear and or see me?
Yes, we can.
Okay. So my concept basically is, since we can't go in any other way, the only way to go in is with a curb stop. And I want to use multiple ways to actually detect and rule out different types of pipe. So obviously a borescope is the best way, because if you can see it, a lot of times you can identify what it is visually. But there are going to be times when you can't see it visually. So this borescope will be part of a tool that can go into the curb stop, and we will also use other ways to rule out what's plastic, what's galvanized, what's lead, what may be copper, and to be able to determine from that. Also, there's going to be times where the curb stop may be covered with dirt and so forth. So we want to be able to cover times where that may need to be cleaned out at the same time that you're actually looking at it. And that's the kind of tool that we're looking to provide, something that could be carried by an individual from place to place, and along with the rules of it, basically either on a wagon or a trailer or something that can be taken mobile.
Excellent. Thanks so much, Marc. And I'm looking forward to seeing how this progresses.
Thank you.
Next up, in 2nd place, being awarded $25,000 along with those additive services, is Salinas Technology. They're utilizing pipe excitation with sensors. And if someone from the Salinas team wants to talk a little bit just briefly about your technology in your own words.
Anyone from Salinas?
Okay.
Hey, yeah, I'm here. I think Dave
Okay.
was going to speak, but Dave, are you off mute now? But yeah, no, generally, sorry about that. We had a bit of a communication issue. Essentially what we do is, as it says here,
hey, Will.
go ahead,
sorry,
Dave, yeah.
folks. Apologize, I was muted. Can everyone hear me now?
Yes, we can.
Excellent. Thanks very much. Salinas is an early stage technology company formed to develop and commercialize a non-invasive methodology to rapidly identify water services. We use acoustic engineering principles and advanced signal processing to differentiate between buried material types. The premise of our patent pending approach is that copper and lead service lines and galvanized have drastically different mechanical properties and physical geometries. Their different densities, elasticity, diameter, and thickness contribute to the pipe's vastly different natural frequencies. If we can excite these pipes at their natural frequencies and successfully identify their unique acoustic signatures, then it's possible to easily identify lead, copper, galvanized, or even mixed pipe systems without interruption of the water supply or access to the home. We are very appreciative of the support offered by the Cleveland Water Alliance and look forward to working alongside with the Alliance in the Waterline Research Facility to further our understanding of acoustic behaviors in different soil types and geographies. Salinas's vision is that our device would provide the final material type confirmation before a shovel is put in the ground. Thank you.
Thank you so much, Dave, for that explanation. And finally, we have our first place awardee receiving $40,000 along with those additive services. We have Global Quality Corporation, or GQC. They're using electromagnetics, acoustics, and AI methods for this particular solution. Does someone from the GQC team want to explain your technology briefly?
Sure, I'll be happy to. I'm Sudhir. I'm the president of Global Quality, and I'm joined here with at least one more team member, Dr. Steve Milroy from Roitronics. And one of our team members, University of Zagreb, given the time difference, couldn't make it, but hopefully in future we will have participation from them. And this is a proposal out of the innovation component of our company, which leverages this approach. And because we have, and the rest of the company has experience in water domain going back to 1993. So that knowledge coupled with the innovation ideas in IoT and telecommunications, such as LoRaWAN and AI, including some of the other innovation products we're looking at. So this was a nice fit within that to explore these two technologies. I'll be leading the electromagnetics part, and Steve will be leading the acoustics part. And again, perhaps a fusion of both to possibly improve the accuracy, because going back to early 1900s in when electromagnetic induction was being used to detect pipe material. So between 1910 and now, clearly there have been advances in a variety of things, but I think great opportunity to revisit the physics and leverage the physics both in the electromagnetic spectrum and the acoustic spectrum with the latest advances in technologies and MEMS accelerometer and soil sensors. How do we bring that together to provide a solution that meets the requirements that were listed? Now, being pragmatic, I'll say, okay, we may not meet 100% of the requirement, but if you meet 80% of market, just even 5 states, how is that market big enough, what value it provides? So ours would be a hierarchical approach saying, what is the lowest hanging fruit and how do we get there? And then the test bed is a fantastic opportunity. Otherwise, Steve was ready to take a shovel and start digging in his backyard yesterday. So it should be a lot of fun and excitement, and possibly even collaborating with the other people who are participating here. So we're really looking forward to it.
Thank you so much, Sudhir. And congratulations to all of the innovators. Thank you for submitting. Thank you to everyone who submitted. We are appreciative to have your brains on this issue. And also thank you to our panel of judges and all the hard work that you put into assessing the awardees. We have a couple of questions for the innovators, and I'd like to just go right down the line. Maybe we'll start with Marc from Utility Technologies, and then go to Selena's, and then GQC. So the first question is, what initially interested you in this challenge? Marc?
Okay. What interested me is I do provide technology to utilities in Ohio and a couple surrounding states. I'm interested in being able to help the utilities that I deal with every day. We deal with some specialty tools, and it also needs to be something that is affordable not only to the Cleveland and Akron and Cincinnati's, but to some of the smaller towns as well. And I think what I'm working on will be something that will be not a super expensive thing that you have to hire a third person or go out and find some kind of government financing to pay for. And hopefully this thing will be solved and all the lead line will be replaced within a few years. So it won't be something that will be needed for a long 30, 40, 50-year investment, hopefully.
Thanks, Marc. And Dave, same question.
Yes, well, we were interested primarily in the lead detection problem because of the scope and severity of the issue. My partners are all from the engineering fields, acoustic, electrical, and civil engineering, and had long recognized an issue around lead and the fact that there was no non-invasive technologies to detect it. Between us, we've done, I believe, 5 startups, a number of them in the municipal space and in the municipal infrastructure space. So we've worked with cities, with state governments before, and we think that we're well positioned to deliver a solution that's really going to help everybody.
Thank you, Dave. And Steve or Sudhir?
Yeah, so the number one interest is we are strongly interested in water. Although it's not as money making as social networking, but water is close to our heart, and so all the problems in water, we like to see how those can be solved in the US, in the developing countries, and that's what been focused. The key reason in this specific challenge is, I think, because Cleveland Water Alliance is great in articulating a specific problem and is important. So when this problem was first announced, a few years ago, then we said, that's a very relevant problem to look into and solve. And so that's what we really started thinking about it, back then at the very first introduction. And the continual support from Cleveland Water Alliance and keeping that seems like it's a problem that's going to, would get additional audience and feedback versus something that you just did it and then what do we do with it kind of a thing. So that's the second part of it. In terms of the solution, going back to our engineering roots, I mean, mine from University of Illinois, Steve from Stanford, but we kind of put our brains together saying, we always have a fundamental approach saying, what exists now in the marketplace and if the solid solution doesn't exist, why it doesn't. And then therefore, doing a solid research of the literature and then saying, okay, these two approaches. Now, although we have generic approaches, there's so many nows to be done within that. So it's kind of a beginner challenge. So the philosophy behind the solution came with, research and some hands-on work and building some prototypes and saying, yeah, it could be done this way. And then the way we would use the fund is, would be between the team for research and, interns and existing employees and kind of who would work on it. And then in addition, Zagreb, interacting with them. And so, a typical way a research grant would get used, but kind of getting the best out of the bang for the money that's going to go in. And therefore, in fact, reaching back to Cleveland Alliance, could you create this thing in your test bed, please? So that, that would be another way of, kind of using them, making the best, getting the best mileage out of the funds. Is that's what we're thinking about doing.
Thank you so much for those thoughtful answers. I guess I'm just going to shoot it right back to Marc if you want to answer the last two questions. What led you to conceive of the solution, and how do you plan to use the money?
Well, what led me to conceive of the solution was I actually had two proposals that would do it acoustically or electronically, but since the rules said that you can't use both sides of the pipe inside the house, I had to rule out the other two, because both that I know how to do, you would have to be on both ends of the pipe. So what led me to believe of just using the curb box is I basically have 5 stents in my own heart, and the heart surgeon actually did all of that from a 1-inch incision in my wrist. So there's a lot of things that can be done remotely with tools that you can manipulate through a rod or a tube or a spring type mechanism that you can operate without actually going in. So that's kind of my conception, is to try to do everything above ground with a tool that can go down and be my miniature hands underground. And as far as how I plan to use the funds, basically to buy materials to put this together. What I'm going to use may be a multiple tubular type device that may require some welding in several different types of configurations as a trial. And that's basically how the funds will be used.
That's really compelling, Marc. Thank you for sharing that. And Dave, would you be willing to also share with us the last two questions on the slide?
Sure, absolutely. So use of funds is going to be to further our research and development effort. We've been working with the City of Toronto, and we're about to embark on another couple of proof of concept projects with them, as well as another city in a different geography in Canada. So we'll plan on using the funds to, as I said, to further our R&D and to get to a minimally viable product that we can actually take out and do field testing with.
Excellent. We are, on behalf of CWA, we're so excited to continue working with the 3 solutions that have been presented here and helping push this technology forward and hopefully solve the problem. So thank you all so much, and thank you for your candor.
I want to just add to that, our judges were really, really excited about these technologies as well. So when we started looking at how we would allocate the funds is really where we further fleshed out the additional support that we would be providing all of you. And I know I went really fast through that slide, but just to touch on a couple of them, we have the utility players here really excited to provide some mentoring on problem solving specifically around this challenge for each of you. And that will also include a chance for each innovator to kind of spend time with all of the utilities together, which, again, represents a little bit of a spread of what those logistics might look like in how a tool would actually be applied in the field. There's also access to doing ride-alongs with utility workers in the field, and CWA will be paying for travel for our different innovators to come into Cleveland in order to be able to access those various assets. So we're really excited. And we also want to kind of open this up. I think that's our next slide. Yes. So I'm going to turn it over to you, Sam, and open it up for some broader questions.
Yeah, thanks, Evie. I know we have some media partners on the call as well. And one question that I've received is where, I know it's been referenced a little bit in some pilots and projects, but where these innovators are based. And how they might have heard about CWA and our work. Emily, do you want to pass it off to some of our panelists?
Sure. Well, not to play favorites, obviously, we're a big fan of everybody, but Marc is local. So I'd like to invite you, Marc, to talk about your engagement with CWA and how you heard about us. I know you're in Oberlin, is that correct?
No, I'm in Lebanon, Ohio, which
Oh,
is
Lebanon,
southwest
okay.
Ohio, just north of Cincinnati, between Cincinnati and Dayton. I've kind of followed CWA on LinkedIn just to kind of see keep up on the industry and so forth when I found out about this. Cleveland, Akron, and Cincinnati are all customers or potential customers of mine. I do business in basically Ohio, Michigan, and West Virginia, and two of the most severe cases of lead problems have been in Ohio and Michigan. We all know who they are, so I won't bring their names up. But it is a problem that's been in the Great Lakes states, probably more than some of the Western states and so forth, based on when lead was installed in the country. And I do like helping the industry local. I work with the local training agencies and a lot of utilities in Ohio and the surrounding states on problems and solutions. And it just seemed like a good opportunity to try to do something to help the industry in Ohio.
Thanks, Marc. And then Dave, you are our neighbors across Lake Erie, correct, in Canada?
Yes, we're based in Toronto, which is only about 5 hours from Cleveland, so certainly within easy striking distance. We heard initially of the alliance and of the challenge through the work that we had done with Toronto Water.
Excellent. Thanks, Dave. And then, Cier, you are our friends on the West Coast, correct?
Well, actually, our main office is in Cincinnati.
So you're local.
And so, I mean, I would ask the question, who hasn't heard of Cleveland Water Alliance and why? No, because our kind of engagement goes back because as the innovation challenges started and the technologies we were interested in, like LoRaWAN, and we were trying to talk to local utilities. This is not when it's popular now, so to speak, getting there. So that's when the challenges and things were coming from Cleaner Water Alliance. We had already engaged with them. In fact, a couple of my people had walked around city of Sandusky, trying to make sure the LoRaWAN went into the Sandusky utilities things, and in fact got an award for that one. So it's kind of a long history. We attended the Water Data Forum sponsored by Cleveland Water Alliance, and variety of other activities, which is kind of too long to list to. So, and then clearly Brian's been across the U.S. been able to take the incubator. One of the successful incubators, and and internationally. So to me, it was another thing on the channel that had just showed up. But and then we all have a lot of relationship with the Cincinnati Water Works, Akron, and I have toured the Cleveland Water Labs, looking at their treatment, and along with. So very strong Ohio, Kentucky, that area history, and then over here in California, along with Steve, and then we're also doing some work in Canada. So kind of aware of what some of the things that are going on in Canada, the Vancouver area. So with that background, then I always see how the Cleveland Water Alliance is clearly pushing the edge of sponsoring innovation in the water sector. So completely tuned with what their efforts for a long time.
Thank you all for sharing that. A couple more questions that have come in. We got a question that came in specifically about the acoustic technology. Now, I know that a lot of these concepts are earlier phase, but this person is wondering how the acoustic systems achieve coupling to the pipe so far underground. So I'm wondering if some of our folks with the acoustic technologies could speak to that a little bit.
Sure. It's Dave Witt from Salinas. and we use a access to the key stop as the ability to couple with the pipe.
Thanks, Dave.
And our acoustic, we haven't completely decided whether to go to the stop. The excitation and in fact, there is a really good research paper recently that surveyed all the different methods, including non-metallic pipes. And so you can thumb the ground, you can insert the excited section, and there are different methods of, and then the frequency used for the acoustic can be ultrasonic, can be very low. And so there's a whole set of questions that get raised saying, okay, how's that going to work? In fact, the current successful one in the gas pipe detection area out of research with the Gas Technology Institute, there's some research material available, but then also it's kind of a combination of thumping the ground combined with it, and these are get categorized as the what they call the excitation, and then elastic wave excitation versus, so a couple different ways, and we are not completely finalized yet. We're going to try and figure out the attenuation with one versus the other. Can we reach 4 foot down, as a kind of bare minimum, and then additional things that distinguishes one material from the other. But yeah, so introducing the signal acoustic, and then you can either receive it at a single point, the same thing that transmit that receives it, or the transmitter and receiver can be separate. So variety of things to be investigated there.
Thanks, everyone. Really exciting. A question for Brenda on the call. I know that Cleveland Water has done a lot to be out in the community and listening to concerns of the public. And I also know that Cleveland Water has done quite a bit already to mitigate lead in schools and daycares. If you could just talk a little bit about the leadership that Cleveland Water has taken there.
Great question. So in 2021, we were able to obtain $2.5 million through wind grants to the federal government, as well as an H2O Ohio loan from the state of Ohio, which was actually a grant itself, to remove all known lead service lines at all child cares in our direct service area, which is Cuyahoga County and parts of surrounding counties. We initially did that work in about 10 months. It was done during COVID. We reevaluated, and some new child cares opened, some other ones closed. So we took all the lead out again. And we also started removing lead service lines in homes where paint issues had been remediated. Those homes are placarded for someone with a high blood lead level. Paint issues had been remediated. It was a really successful program, and we learned a lot of lessons from that, which gave us a head up in applying for bipartisan infrastructure dollars. So on August 7th of this year, we have began undertaking our year one of a system-wide lead service line replacement, where we can spend bipartisan infrastructure dollars to take out lead service lines proactively. Our water is really good, even if you have a lead service line. So we just want to get the lead out while there's funding available to do that, where we can use that funding. And so we're doing about 80 to 100 lead service line replacements a week now.
Wow, that's incredible to hear, Brenda. Thank you. And yeah, thank you, EBF. If you want to call on some of our other utilities here, that would be great.
Yes, actually, all of the utilities that are on the call with us today have, some pretty significant efforts they've been putting in to date as well. So I just want to give our partners here a little bit of an opportunity to speak to that. So, Esther, why don't you start us off, and you call on your next colleague from another utility. Scott, are you there?
There we go. Couldn't find the unmute button. I'm Scott Meglane with Akron Water. We are a neighbor of Cleveland Water. We've done a lot of work towards removing lead service lines. We're in pretty good shape where we are. We, like Cleveland, also have really good water quality. Our lead and copper monitoring results are excellent. We're in a position where we expect within the next 2 years or so to be completely lead free, and have removed all known lead service lines. Our remaining challenge will be addressing the 8 to 10,000 estimated galvanized lines that are requiring replacement that we anticipate under the upcoming federal rule improvements. So I think being on the private side, that's where these technologies will be helpful for us to not go into homes, but to be able to do it from the street with relative confidence that a $1,000 dig up cost to take a look at that line will lead directly to replacement because we know it's there before we even dig. So that's our story. We're looking forward to this. I enjoyed reading the proposals. There was a lot of technical information in there, and I'll be honest, it took me 3 or 4 times to read some of them just because the technology is there and the technical nature. But it was a good read, good ideas. I'm looking forward to working with you guys.
I just want to say thank you to everyone here, and thank you for all of the engagement from our utilities and from the industry as a whole. As I said, so many different organizations out there that are working on this, that are really interested in the results of this specific challenge and the innovations that are coming out of this challenge. We're really excited to work with each of you innovators and to get you the support you need to help solve this really critical issue for the industry. Thanks everyone for joining us, and have a great rest of your week.